interesting, all that discussion, because it's always the same. Mark, you know, I know, anyone who speaks to builders and tries to make these cases, you can't get away from a presentation without all that discussion about the appraisal issue and how to recognize the value. So it always is big. And as Rick was saying, there is a lot of overlap. You know, Cliff talked about market transformation. I'm talking about, or was assigned, code, standards, and rating systems, kind of the same thing. But I'm kind of coming at it from a different perspective. Cliff is looking at enforcement as his key message and key point. And I think I'm looking at code, standards, and rating systems from a systems perspective. If Cliff and his efforts are successful to increase enforcement, that still will not get you the energy savings you're expecting if the whole system approach to how we implement more efficient construction isn't also applied to new buildings. So we can have more rigorous codes and actually not get anywhere near the savings we're projecting, and at the same time possibly do harm, increase the risk of moisture issues, or increase the risk of indoor air quality problems. So from my perspective, enforcement's important, but what may be even more important is this idea of code, standards, and ratings as a system. So that's what I'm going to speak to. Let's again begin with the context. You've heard it too many times today, but the residential sector is really important. It's about the latest numbers I've gotten from first quarter 2012. It's almost 5% of GMP. And if you add all the other housing services, residential construction's at almost nearly 20% of GMP. So when the residential sector goes down, that's a big thing. And in terms of this country's business sector, there's very few things that we make in this country anymore almost wholly like we do housing. And of course we know once those homes are up, they're the second largest or the third, well, they're the top most consuming sectors of energy. So we really, if we want to address energy use in our country, we have to go after the residential sector. Okay, so what are the challenges? If that's our situation, very big part of our economy, very big part of our energy sector, what are the challenges that we're facing? And first, in most industries, you have about 3, 4, 5, 6 major producers. There are about 3 major car companies. In most computer products, there are about 3, 4, or 5 major manufacturers. And the difference is when we get to, and there's this very small number that really shows up on the scale, but when we get to housing, there used to be 100,000 manufacturers, now maybe it's 80,000 manufacturers. That's a lot of players. And then on top of that, there are about 70, 80,000 remodelers. It's incredibly difficult to address transformation and innovation in an industry with that many individual players, not to mention how underfunded they are to invest in innovation. And then as a result, what you see happening is that if you look at corporate America, the latest numbers that I've gotten from my research is that the average investment in R&D as a percent of revenue is nearly 4%. Now, there are no numbers for home builders. So I just kind of made it up a number. It's like 1/100th of 1,000th of 1% of their revenue go into R&D. And it's not their fault. There are about 80,000, 90,000 players. They're underfunded. You can't expect the housing industry to have a big pool of money to put aside to ensure innovation happens. And that is a major issue in the sector. Okay, so here are the challenges kind of summarized. Where innovation is going to come from. We need research and development. We need to get housing to keep moving up, and ever more so in this new normal where new homes have to be competitive with 95% of the competition, which are used homes, so much at fire sale prices as we still recover from the market slowdown. Second, we need metrics to ensure performance and measure performance. We need leadership demonstrating that high performance is a good business case. And last, we need transformation, codifying high performance in standards and codes. Okay, so let's see how we respond to these challenges with standards, codes, and rating systems. And so I'm going to look at 4 major programs that represent codes, standards, and rating systems, and some of the source of innovation. That source of innovation is Building America. And when I speak to often why I went from Energy Star to Department of Energy, one of the main reasons was this opportunity to be at the source of innovation. Building America is the nation's world-class research investment in key innovations for high-performance homes in the marketplace. Then we have rating systems, which provide the metrics, labeling programs to bring forward the leadership, and lastly, the codes and standards to complete the market transformation. Okay, so I'm going to talk first about the Building America program and how it goes about delivering innovation. I think I was only on board for a month or two when I was asked to kind of frame a roadmap for the innovation from that program. And first you have to know where you're headed. And where Building America is headed is zero net energy ready goal of about 50% more efficient than a 2009 IECC home. And in lay language, those are homes that are so efficient, a small renewable energy system will offset most or all of the energy used by that home. And the way we've been getting there is by reducing the thermal loads in buildings. So mapping out a roadmap, what's really happened when we first began to recognize the energy issue with the oil embargoes and sense of energy crisis in the 1970s is we had a very high thermal load, and immediately the research recognized that we had to prioritize reducing the loads that were being caused by the thermal enclosure. So if you look at most of the research that was happening in the 70s, it was mostly focused on insulation, double pane windows, a little bit of air sealing. Then we get to the 1980s, and the thermal loads being reduced, and now we're really getting to the super insulated home concepts. Much, much more insulation, much more air tightness. The low E window comes into play, so we're really getting that thermal load significantly reduced. Then we get to the 1990s, and we realize the loads are getting so small that we, in addition to continuing to understand the thermal enclosure, we have to now manage water flow in buildings. We're in fact causing potential harm if we keep tightening and sealing and insulating these homes and don't recognize that they no longer have the ability to dry. So water management became a very big research priority. And then we recognize also if they're tighter and better insulated, we have to ensure fresh air and indoor air quality. So those two elements pop up as additional research priorities. Then we get to the past decade, 2000 to 2010, we continue to keep understanding thermal enclosures, make them better, and water management, and IAQ and ventilation. And now we recognize that the loads are even so much smaller that we need technology solutions for low load homes that are so low the current HVAC systems no longer seem to be amenable to those homes working as well as they should. Then we get to our current decade, and we have all those same elements, plus we're recognizing that now the balance of systems are a really important part of the energy consumption. So efficient components and miscellaneous electric loads crop up, and we'll also come to this awareness that the transaction process is substantially broken. We talked about the appraisal issue. We charge the same rate in a mortgage interest for a high-performance home as a minimum code home, as an existing home. That is completely broken. We charge the same insurance rates for a low-risk home and a high-risk home. And on top of that, we have a complete sales infrastructure that has no skill sets and training to sell high-performance homes. Almost every element of the transaction process is broken, and research can substantially move that and improve that situation. Things like measuring performance metrics for builders who build high-performance homes and so forth. And then what steps up to is the realization that building integrated renewables has to also factor in as we go to net zero. And lastly, as we go to the next decade, 2020 to 2030, all those continue to mount up increasing importance, and we kind of come up to a position where we're truly ready for net zero homes. And in fact, we know how to do net zero today, but all these elements have to somehow come into play. So that's kind of the roadmap on one page that I try to put together for Building America, but it recognizes this path we have to go on for whole systems. So the rating systems we have are kind of, in my mind, three parts. One is the HERS rating, 2 are point systems, and 3 are checklists. And what we have to do is recognize the strengths and the weaknesses and complementary nature of all these systems. HERS are great for setting a performance baseline, but any software-based rating system is pretty weak at integrating innovation. So if I have a choice between putting in a more efficient water heater or a structured plumbing system, my HERS rating system won't know what to do with structured plumbing, so I get no recognition for structured plumbing. And yet it saves me 10% of my water heating load, and it may save me 6,000 or 7,000 gallons of water consumption that would normally be wasted, and I choose instead to do a 10% improvement water heater. I wind up making the wrong choice because the HERS metric doesn't recognize innovation. The same thing with, it will tell me to do a high performance window, but if I can have a little extra resources with a slightly less efficient window, but more resources to do complete flashing details that will ensure the window will never leak, I won't see that come out of a HERS rating system. So we have to be very careful when we use rating systems and performance-based systems that they don't recognize systems approaches and they don't recognize innovation, and often they have built-in biases. With the HERS rating, I get a much better score for the exact same specification if I do a 10,000 square foot house than if I do a 1,000 square foot house. I get a much better score for an oil-heated home than a gas-heated home than an electric-heated home or cooled home. And I get better scores for certain locations, even with the exact same specifications. So we need to understand that performance-based systems are good often for baselines, but they have biases and they are limited on recognizing innovation. And therefore, it could sometimes block innovation if they become the institutional requirement that you have to construct to. Point systems are great from my perspective in terms of creating a system that people understand and know how to use and setting tiers, but they don't typically ensure complete systems. And checklists is often what you've seen me historically go to ensure complete systems. I know people don't like them because they're perceived as heavily prescriptive, but there are ways of doing checklists so they're not quite fully prescriptive. They allow a lot of choices, but make sure your systems are complete. Okay, so then we can recognize leadership, and we have lots of choices. It's almost like NASCAR out here. Under energy efficiency, we have Energy Star, which is an above code program. Then we have the DOE Challenge Home, which is a zero net energy ready label for builders who are even ready to go further. And maybe the top tier is the passive house label for builders who are going to maximum efficient performance. Then under green, there are about 30, 40 different labels you can go to. Three of the most common are the NHB Green Building Standard, Lead for Homes, Earthcraft, and there are a whole array of other labels. All of those labels that I know use the point system approach with bronze, silver, gold, platinum, and tiers, and that's the way those programs are set up. And then there are all sorts of special attribute labels. Air Plus by EPA, WaterSense you've heard about, Fortified for Safer Living is a disaster resistance label by the Institute for Business and Home Safety, an insurance hosted organization. And the labels keep going on. It's almost like label fatigue is a certain risk that we're confronting. But we have lots of choices, and all of these are good for recognizing leadership. Okay, so let's look at how these programs work and look at a systems approach. Now, with Energy Star, for me, the goal was to get to complete building science. And when I got there, it was an incredibly good feeling. And the way we got there with the last version 3 specification was we used a rating approach for the baseline. A HERS rating basically determines that you are eligible to play. And so the reference design is based on getting a HERS score that's customized for each home. And it's set so it eliminates the biases that I mentioned about size and fuel and so forth. And then we have the mandatory checklists, or checklists again, to ensure complete systems. And that equals Energy Star. So the way I use the rating system with Energy Star to ensure complete systems is with a hybrid of a performance as a baseline and then checklists to make sure the systems were complete. And in the case of the building science approach, airflow, thermal flow, and moisture flow. Now with DOE Challenge Home, we're looking to do a zero net energy ready specification, and the system gets a little bit more complex. You have complete building science by making Energy Star as a baseline. Then you ensure proven innovations and best practices with a set of checklists that make sure the Building America proven innovations are brought into the marketplace. So the ducts have to be inside the conditioned space. Air leakage has to be half of Energy Star. The insulation has to be at least 2012 IECC or better, and so forth. So you get those proven innovations, and then you ensure the components inside the home are energy efficient. So you have another prescriptive list of requirements to make sure that components are efficient. What we're doing here is step by step, ensuring that we're minimizing the load so much that we've done everything we can before we go to that renewable system. Then, if you have homes that tight and homes that well insulated, you have an obligation to make sure a comprehensive approach, not a point approach, but a complete system approach to indoor air quality is taken Then you want to be solar ready, so if someone can add solar in the future, with simple details that cost hardly anything but could save thousands of dollars downstream when an owner is ready to put in solar. Water efficiency is next. With Challenge Home, we're initially encouraging it and requiring efficient water, hot water distribution. Then disaster resistance shouldn't be ignored, so we're encouraging that, looking forward to requirements in the future. And lastly, quality management. If the builders don't do these kinds of complex approaches to new home construction with a lot more attention to quality approaches, they're not likely to be successful. So you can't ignore quality as well. And that whole package is the Challenge Home. And then very simply now, we think then you're ready for renewable ready. And what normally happens is a lot of people just do some basic energy efficient improvements and jump straight to the solar system. So we're trying to create a framework for how to do practical net zero energy ready homes. And then all this is working in terms of a transformation process, as you've seen several times today, this slide. It's amazing how fast the code's going up. If the 2015 goes to where it was intended, that would be a 50% jump above the 2006. Amazing growth in how innovation's moving to the marketplace. But this doesn't help us if all they're doing is ratcheting up R value and ratcheting up equipment efficiencies, whatever it may be. It has to look at whole systems. How does all this work as a system? Well, in fact, a lot of these programs are better integrated than you may think. When Building America Phase 1 was introduced, it was an incredible springboard that helped launch Energy Star when it was in its doldrum days trying to find a HERS infrastructure. Without Building America at the beginning, Energy Star would have had a very difficult time jumping into a prominent program. So very critical link there. And Energy Star was based on MEC 93 when it was introduced in 1995. And then the 2006 code comes in. That informs Energy Star version 2. Building America Innovations jump into version 2, mostly in the form of the thermal bypass checklist. And then we introduce Builder's Challenge, again based on Building America Innovations. And Building America moves to a phase 2. Then 2009 IACC becomes the baseline for Energy Star version 3. DOE Challenge Home becomes the transformation from Builder Challenge, almost like a version 2. The Building America Innovations inform the Challenge Home, and then we have Building America Phase 3 that we're in right now. We have the 2012 IACC, which will likely be the framework or foundation for Energy Star version 4. It's a baseline for the Challenge Home, and all the innovations keep kind of working through the system. So what are the lessons learned to kind of wrap all this up? Well, high performance is the goal I think that most of us would agree upon. And so the goal of high performance is affordable, comfortable, healthy, durable homes. And we've heard that mantra so many times. And what that requires is a comprehensive building science approach, not parts, a comprehensive approach to efficient components, a comprehensive approach to IAQ, water efficiency, and disaster resistance. It's kind of foolish to make a building that deserves and will last hundreds of years only to be undermined by a disaster. We have to start thinking about disaster resistance as a key component of high performance homes. So to maximize home performance, code standards and rating systems must ensure complete systems. It's great to get them enforced, but if we don't also work to get those codes to be systems-based, we have an issue. So what are the systems? Well, building science as a system is airflow, thermal flow, moisture flow. And the way we're getting that with Energy Star version 3 is with thermal enclosure checklist that looks at insulation systems, air sealing systems. It looks at all the window efficiency and so forth. That is critical to the airflow, thermal flow, moisture flow. High quality HVAC quality installation is essential. Often we're installing heating, cooling systems, and they may lose 20, 25% of their rated efficiency because the practices for how we install HVAC are virtually at a very low level. And so there are two checklists, one for the rater, one for the builder, and a water management checklist to manage bulk moisture. So when we go to codes and standards, we need to make sure those systems are part and parcel where the codes are going. Thermal enclosure is a system. Again, there are many components: airtight construction, high performance windows, adequate quantity of insulation, and most critically, high quality installation practices for insulation, complete air barriers, and minimal thermal bridging. Leave out any one of those components and your thermal enclosure is compromised. So which part do you want to leave out of the code? Which part do you want to leave out of a rating system? I believe that the whole package is required for a good thermal enclosure system. It's not the priority for codes to keep going higher and higher R value. The priority for codes at this juncture is to make sure all of these 6 components of a thermal enclosure system are now part of the requirements. In terms of HVAC systems, you need efficient equipment for sure, but you won't get the performance you expect unless you also look at the system design, testing and diagnostics for airflow, refrigerant charge, and so forth, and you ensure combustion safety. So you can't just go along and just keep increasing AFUE requirements or C requirements for equipment in the standards. The standards have to say we're more than just the equipment. We're better than that. If we have a standard, it has to expand its boundaries and not just be the equipment rating, but how the system gets installed. Water management as a system. You cannot make buildings where the codes have gone at this juncture, 2009, 2012, 2015. You've now gotten to points where you're creating the worst house allowed by law is one that cannot dry. When the worst house allowed by law cannot dry, and the code doesn't have a comprehensive set of requirements for water-managed roofs, walls, foundations, and materials, you are not ensuring the safety of the public. So you have to look at codes to get into this entire systems approach to how we control water. And then indoor air quality, we cannot make homes this tight, make them this well insulated, and not do source control, dilution, which is another term for ventilation, and filtration that actually works. The latest research from Lawrence Berkeley National Lab suggests that PM 2.5 is the most significant pollutant in homes, yet filtration that comes with a standard home doesn't do hardly any effective removal of particulates from the air. So we need codes and standards that enforce that as well. Water efficiency is 3 parts. It's the fixtures, which is the easy part, the hot water distribution, and then the landscape and irrigation. Disaster resistance is the weather. It's the hurricanes, the tornadoes, and natural events are floods and wildfires. And what's often missed from from disaster resistance, because insurance companies don't cover this, is pest resistance. Now, in the Gulf region, the Formosan termite can eat a whole house up in virtually 9 or 10 months. It's about 5,000 times more voracious than a normal subterranean termite. To build a house in the Gulf Coast, and now they're moving up much, much faster than they expected further north, not to build a house that can resist termites is, I think, a serious omission in new construction. So disaster resistance for all these 3 components would be a complete system. Okay, so if I'm going to wrap, I just want to say one thing. So you know my message here is that this is all great that the codes, ratings, and standards are getting better, and we have to look at systems. But also, the last point I want to leave you with is we had a meeting for Building America in July, and we ran through all these key issues that we think are confronting the housing industry today. And it's amazing sometimes how the solutions are not what you expect. And when we came into the issue about codes and the challenges, and we looked at how do we get the housing industry to do better, and you have issues with enforcement, and how do you get your codes to have the right technical requirements, there was an amazing suggestion that came from the audience during that discussion. And someone said, just make it code one line, a one-line code. You're only allowed to do 1.5 tons per, 1 ton per 1,500 square feet of home. 1 ton of cooling and heating per 1,500 square feet per home. What happens is that forces the industry, because they only have a limit on how much cooling they can provide, to make sure the house has absolutely high-performance thermal enclosures, high-performance windows included, has the best air sealing, and has to work with that limit. And so sometimes you can get to your outcome from the back door, even though it's practically not possible that you could do that. It's interesting how solutions like that sometimes get you what you want, yet they have nothing to do with a normal approach, where you simply keep getting more and more technical specifications and more rigorous code enforcement procedures, simply only allowing the industry to have a limit in how much cooling or heating they can provide will force them to do better. And whether that's the solution that works or not, I only bring it forward because it struck me such an amazing idea that you can get exactly what you want with one single line. Thank you very much.